problem number 5, I just worked this problem out and I'm just going to talk you through it because there's a lot of writing in this and I thought that would just make the video smaller. So let f of x equals x sine of pi over 2x. The graph of f is shown here on the interval from 0 to 2. Part A. Determine whether the mean value theorem applies to function f on the closed interval from 0 to 2. If so, well, first of all, it says determine. It's one thing we have to do. I like to put a box around the essence of the question to know how many parts that we have to do. If so, find the point or points that are guaranteed to exist by the mean value theorem. Well, let's first determine if it applies. And I'm saying it does. The mean value theorem applies for these two reasons. One, f is continuous on the closed interval from 0 to 2. F is also differentiable on the open interval from 0 to 2. It's continuous because there's no breaks in the graph. We can see that if we were to check this graph out, there's no holes or vertical asymptotes. It's differentiable because there are no cusps on this interval. So what is the mean value theorem? Well, it tells us that there guarantees a value of c, so that's some x value that we're calling c, on the interval from 0 to 2 such that the instantaneous rate of change is equal to the average rate of change. So the slope of a tangent line is equal to the slope of a secant line. To find the slope of a secant line, that's the right side here. You take the slope like you did in algebra 1, change in y over change in x, f of 2 minus f of 0 over 2 minus 0. We're using 2 and 0 because that's the endpoints of this interval. We can see from the graph f of 2 is 2, f of 0 is 0. That's why this is 2 minus 0, we end up with 1. So essentially this question's asking, is there a place on this graph where the tangent line to the curve would have a slope of 1? So if you find the instantaneous rate of change, the derivative of f, derivative of x is 1, derivative of sine of pi over 2, I have to use a chain rule for that. Derivative of sine is cosine, inside function stays the same. I just change the x's to c's. It's usually what you do on the mean value theorem. I'm going to leave them as x's, that's cool too. Then you multiply it by the derivative of the inside function. The derivative of pi over 2c is just pi over 2. Now we're going to solve this equation. So I subtracted 1 from both sides, giving me 0. Divided both sides by pi over 2. 0 divided by that is 0. Then we get here, we use cosine inverse to both sides. So pi over 2 times c is cosine inverse of 0. So when does cosine equal 0? It equals 0 when the y value is, when the x value is 0. That's on the positive y-axis, which would be at pi over 2 and 3 pi over 2. That goes back to the unit circle. To get c by itself then, multiply both sides by 2 over pi, or dividing by pi over 2. This gives us 1. This here gives us 3. So there are two possible answers, but if you reevaluate what it asks from 0 to 2, 1 is in the interval from 0 to 2, and 3 isn't. So I drew the picture here. This line here is the secant line. Its slope is 1. This here is a tangent line that's parallel to that because its slope is also 1. And that's happening when it's the point 1. We can see how that is a parallel slope. That's part A. I don't know if your professor requires all this information. Maybe you can just say it does apply. If you need all the information, then I would write down all of that. B, find L, the linear approximation. I guess I didn't finish this problem in hindsight. To f at a equals 1. The reason I didn't finish it, it says find L of x. I didn't actually write it that way. So to do the linear approximation, what this is asking you is to find the equation of the tangent line. To find the equation of a tangent line, you need two things. You need a point and a slope, so you can put it in point-slope form. To find the point of tangency, you simply take the original function and you put 1s in for all of the x values. And that's what I did there. And I found out that f of 1 was 2. So my ordered pair is 1, 2. Then I found the derivative, and I put 1 in place of x, and found the f prime of 1 is 1, which means the slope is 1. So I didn't finish this problem. I'm going to finish it now. Point slope form, I think that you remember, hopefully, is y minus y sub 1 equals the slope times the difference of x and x sub 1. Replace m with 1, and this ordered pair goes into y and x, which gives us this equation here. Since it says to find L of x, we want to get y by itself here. So we're going to have x minus 1 plus 2. So that means that L of x is going to be x plus 1. Cool? Cool. So that concludes that. This is the official answer for that. This last part, use linear approximation from part B to estimate f of 6. If I'm writing L of x that way, then I guess I will re-show my work. So we can use 6/7, which is really close to 1. We found this linear approximation at 1. 6/7 is super close to it. So we can use this equation to get this approximation. 6/7 plus 1 at 7/7, that's 13/7. And then there's two parts of this. Estimate this, and then is it an overestimate or underestimate? So this is my official answer, and then I'll go up to the graph and show you why. This estimate is an over approximation because the curve is concave down. Now that might be enough for your professor. If it isn't, I would also say this, meaning the tangent line is above the curve. So let's look at this and let's explain why this is an over approximation. We used this red line to approximate 6/7. 6/7 is about here someplace. So the answer we got is the y value of that point, but the actual y value of that point is down here on the curve. So it's an over approximation. It's a number that's bigger than the actual answer. Cool? Cool. That concludes number 5.